Okay, well, the example I gave yesterday was a table, and I showed how you could just write the results, or you could draw the results. Now, because I haven't got much space, maybe you can put your results on a separate sheet, but I'm using this, and I haven't got much space. So I will use just a table, and I'll write my answers in. You need a lot of space. I can't remember how many objects we're testing, because of course that will dictate the size of the table. So we had paperclip, coin, possibly a fuse, resistor, dog, hand, anything else? No? Okay, maybe then I need 7, I need an extra one. How bright, I'm just using shorthand, you can write it longer, so how bright the bulb is, and then we put each item in here. So we're going to start with, how many is that? 1, 2, 3, 4, 5, 6, yeah, okay, so we'll start with coin. Let's have a look then. So I'm going to open up the experiment. Yeah, we'll go through one by one, yeah? So now I'll open up the website, which is this brainpop.com. It's the same one we've been using a lot of times in our IPC lessons. So first of all, I need a battery, wire, and we said to keep the test fair, we have to carry out the same experiment, but we just change the thing that we're testing as a conductor or insulator. Now with this, we can do it like that. So I said we'd test the coin first. Let me find the coin, here it is. So I attach it, okay, I need to move. So how bright shall we say that is? Quite bright? Yeah? Okay, we'll just use the word bright then. Yeah, because it's important, excuse me, that we measure, that we describe the brightness. So that's the standard brightness. Right. Next thing, what shall we, well, Ahmed said paperclip, so we'll do paperclip. So now I have to delete this coin, and I'm going to place the paperclip in there. It's the same, isn't it? Right? I would say it's the same brightness, so we are again going to write in the Word document, bright. What's the next item you want to measure? Hand. Okay, we did, hand was mentioned first. Okay. Well, we've chosen hand now, so just let's go with that. And I find the screen to test it on. Hand, nothing. What shall I write? Nothing. Okay, we'll do the fuse next. A lot of people have asked for fuse. One moment. Okay, click on hand, delete, and look for the fuse. Let's see. It might do, we don't know. Okay, that's quite a good conductor. Again, I would say it's bright. I think it's the same as the other brights. Yeah, what I can do is I can place a bit of wire here. That's to measure it. See, it goes to the bit of wire. Now, we tested a coin before, so let's see if the coin is any different in terms of brightness. Where's the coin? Here. Okay, it's the same. See, it reaches the wire. Okay, that's one way of testing, because of course it's difficult, you can't get a ruler exactly. Well, I suppose you could put a ruler on your screen, but we can see now if it goes to the wire, then it's the same brightness. Okay, what's the next object we are testing? So the dollar bill or the paper money. I think I need to add some columns, paper money. Yeah, I've written paper money. Okay. Cut. Why can't I get rid? Oh no, I don't want to get rid of the bulb. Is the dollar bill. And again, so we write nothing because we want to use the same language each time. Next item. Let's see. Can I insert a column to the right? And we think that, but of course with an experiment, you have to test everything to keep it fair. Even if we know more or less that it won't work, we have to try it out. So here we go. And rubber or eraser. And there we go. As we predicted, nothing's happening. So again, nothing. What else? Dog. Yeah. Well, the reason... Well, let's have a look. Let's see. Okay. Dog. And again, nothing. So we need to return. And write nothing. And what are your predictions? Yeah. Well, do you remember when we did it last time? Let's see. Do you remember we did this before? It does work, but right, good. It's good that we tried them all. So dim, yeah, because pencil contains graphite, which is a conductor, but not a particularly good one. Yeah, it's called lead. They used to use real lead in the olden days, but now they don't use real lead because lead is actually quite dangerous. It's not healthy. It can make you sick. Have we done all the items? Let's have a quick look. Oh, I think there was something else. Yeah. There we go. There it is. So a resistor. Let's have a look. Yeah, okay. Nothing. The clue is in the name. Resistor. Yeah. It will resist electricity. Let's have... No. I need to add another column here. So we've got quite a few items. I think it's 9 altogether. So it's just called a resistor. Okay, and it again nothing. Let me just check that we have all the items. We did fuse, and all the other things are just stuff. Oh, there's a different kind of resistor. Well, we can try this one, but it will have the same effect. It's just a different color. Whoops. Yeah. Oh, hang on. Let me try the other resistor. This one is a bit brighter than the pencil. Let me check, because now that's confusing. This resistor did nothing. Or did I not connect it properly? No, it didn't do anything. Yeah, it's better at resisting. So a resistor limits the amount of electricity that goes through, but obviously this one allows some to go through. What we'll do is in our table we'll write resistor 1 and resistor 2. Okay, so that shows that some resistors allow electricity through and others do not. Right, I need to... now, the brightness, it was brighter than the pencil, wasn't it? But it was dimmer, and I've got my shroom here, but it was dimmer than, I'll just put R2, than bright, wasn't it? So I'll put a bit dim. Yeah, or you could put a bit bright, depending on how you want to do it. Okay, right. So that's our results done. So what can we see? What do we learn from these results? We spoke about this last lesson. What do we learn? Any idea? Well, we learned that the brighter the bulb, the better it is as a conductor. Okay, and now we have some other information as well. We've got some results. We can also see that metal things conduct. So metal, a resistor is made with metal in part, so that will explain why it can conduct. And I suppose the insulators we have are, according to this, are what? So the insulators, according to our experiment, are hand, paper money, and rubber, and dog. And we've got one kind of resistor, so we can put, we think this because things that have metal in them conduct, and things that don't have much metal in them are insulators. Yeah? Okay, so this is my reason. You can change the wording or you can change it completely if you have a different reason. This is just my idea. You might have your own ideas, and you might write it differently as well. You don't have to copy exactly. Our results do not prove our hypothesis. Now, I don't know if you can remember yesterday, we wrote this hypothesis. And this is what we predict. Were our predictions true to the hypothesis? Well, I think our hypothesis was more or less this. Yeah, that metal conducts. So our hypothesis, the results did prove that metal things conduct. However, in the case of the resistor, there was a contradiction, or it didn't prove our hypothesis. Okay? What we found out, the results did prove our hypothesis, because the things made of metal did make better conductors. However, the pencil and the resistors did not prove our hypothesis. I'll just put a full stop there, breaks up the sentence, then it's clearer. The pencil conducted electricity even though it is not made of metal, and the resistors were bad conductors even though they are made with metal. Yeah, so there's a bit of a contradiction. Overall, metal things do make better conductors, but there are some exceptions to that rule. For example, water is also a conductor, we know that, but it is not made of metal. It is not metal. So we could improve our experiment by testing more objects. Okay, so that's one example. We could use different things, like a buzzer. We could use a buzzer and test the conductivity through the loudness of the buzzer. We could use a buzzer instead of light, because it might be easier to hear the difference in the sound than see the brightness of the bulb. We could use more batteries, because some of the things might be conductors, but the power isn't strong enough to go through them. Yeah, if we used more bulbs, we could see maybe more accurately how good a conductor something is.